The lesson topic for this video is compound probability, independent versus dependent events. Okay, so the situation here is we have two or more events that happen back to back. So that means I might roll a die and then flip a coin, and we would want to know the probability that we were, for example, correct on the number we chose for the die and correct for heads or tails. Okay, so two events happening one after another. We need to know if these events are independent of each other or dependent of each other, or on each other, I should say. Independent means the occurrence of one has no effect on the probability of the other. Okay, meaning if I rolled a die and I got a 3, does that have any effect on if I can flip heads or tails? No, no effect whatsoever. So rolling a die and flipping a coin are what we call independent events. One does not affect the other. Dependent events, on the other hand, are when the occurrence of one changes the probability of the other. An example of that might be if you are using a deck of cards and you want to know what is the probability that the first card that is dealt to you is a queen, and then the second card that is dealt to you is an ace. Now, if you keep the first card in your hand, then the probability of the second draw, whether you get an ace or not, is affected by the fact that there are less cards in the deck now. Okay, so the original number of outcomes was 52. So there were 4 ways of getting a queen out of 52 for the first dealt card. And then the second dealt card, there's still 4 aces that we were trying to get for the second card. Remember, we were trying to go for a queen and then an ace. Okay, but now there are only 51 cards in the deck if you had been dealt one. So again, this means that the second probability is impacted by the first situation. Let's look at some examples. So just answering quick, are these independent or dependent events? Number 1, if I flip a coin and I roll a die. Okay, these are independent events because no matter what I flip, if I flip heads or tails, it doesn't affect how I roll the die. Okay, number 2, roll a die twice. So if I roll a die and then I roll a die again, is the second roll dependent on the first one? No, it is not. So they are independent again. Number 3, if we select a green M&M and then eat it, let's say there's a bowl of M&Ms, right? Bowl of M&Ms, there they are. There's one, there's one. Okay, so if I have some M&Ms in there, okay, if I select a green one and I eat it, and then I want to select a blue one, and I'm trying to figure out the probability of that happening, notice that since you ate the green one, the second draw, trying to get a blue M&M, for example, has been impacted or is dependent upon the fact that you changed your sample space. So this is dependent. All right, the next two are both about cards, and look at the difference between them. Number 4, select a card from the deck, keep it in your hand, and then pick another card. Versus number 5, select a card from the deck, look at it, and then put it back in the deck, and then pick another card. Okay, notice that this situation is independent. The second situation, the second event, isn't impacted by the first one because we put the card back. However, this is dependent because, again, you selected the card and you keep it in your hand, and now the sample space has been impacted for the second draw. Okay, so when are we using this kind of situation with independent versus dependent? Well, again, it's when we have more than one event that's happening one after another. So I draw a card and then I draw another card. Okay, so this phrase, we've talked about the word and meaning multiply before, but it's probably better to say that when we hear and then something else is happening in the second event, that is when we know, again, and right here, and then means we're going to multiply our probabilities. Because think about it a second. If I said I was going to flip a coin, okay, there it is, yay. All right, and I want to be correct 2 times in a row because somebody said, hey, if you're right 2 times in a row, I'll give you $100. Okay, so what's the probability that I'm right 2 times in a row? Well, I have to find the probability of being right 1 time and then being right the second time. Okay, and when we multiply fractions, what happens is, and this is when they are proper fractions, the solution ends up being a smaller value, because being right twice in a row should be less likely than being right only 1 time in a row, if that makes sense. We'll get into this more as we go. But for dependent events, remember, when they're dependent, when the second draw depends on the first draw, for example, remember we need to change the total number of possible outcomes of the second and third and fourth events, or however many there are. Let's take a look at some examples. All right, A. Every morning, one student in a class of 24 students is randomly chosen to take attendance. What is the probability that the same student will be chosen 2 days in a row? Now you're probably thinking, I hope you're thinking, not very likely. Okay, let's just think for a minute, what's the probability that you are chosen? Okay, well, you are one student out of 24 students, so that is the probability that you're chosen. And that value is, just so you know, 0.042. So you only have a 4% chance of being chosen. So what's the probability that the same student, again, let's just say you, were chosen 2 days in a row? Well, again, that's going to be less likely. I mean, we're already at 4% likely that you'll be chosen the first day. So what happens here is we're talking about 2 events, the first one and then the second one. Okay, so the first day, you have a 1 out of 24 chance of being chosen to take attendance. And then, so this is the second event, so we're going to multiply. You have, once again, a 1 out of 24 chance of being chosen again. Notice, these are independent events, because it doesn't say anywhere in the example that once your name is chosen, that you're not going to be chosen again until everybody else goes. Okay? So you still have a 1 out of 24 chance, out of 24 chances of being chosen the second day. Well, this probability now, and remember when we multiply fractions, we multiply the numerator and the denominator. So 1 times 1 is 1, and 24 times 24, well, that's actually 576. Now, if I divide 1 divided by 576, I can tell you that it is very unlikely, like we said. 0.002 is the probability. That means less than 1% and far less, okay? So very unlikely, and definitely less likely than being chosen just 1 day in a row. The second example, you flip a coin and roll a die. What is the probability of getting heads and an even number? Well, first of all, you have to ask yourself the question, are these dependent or independent events? And the answer again is they're independent. Flipping a coin and getting a certain number or certain thing, heads or tails, does not affect rolling the die. So all we're going to do is multiply our probabilities. So flipping a coin, what's the probability that you get heads? Well, heads is one side of a coin out of 2. And then you want to get an even number when you roll the die. How many numbers on a die are even? 2, 4, and 6. So that's 3. Out of how many sides on the die? 6. We are going to multiply our probabilities because we want to be correct and get heads and then even for 2 events in a row. So 1 times 3 is 3, and 2 times 6 is 12. If we reduce that, that's 1 over 4, which is 25%. So there's a 25% chance that you get heads and an even number. C, you roll a die twice. What's the probability of getting 2 6s? Okay, so first, is it dependent or independent? Well, once again, rolling a die doesn't change the next roll. All right, so they're independent. When you roll a die, what's the probability that we get a 6? 1 out of 6. If we roll it again, what's the probability that we get a 6 again? Well, still 1 out of 6. 1 times 1 is 1. And 6 times 6 is 36. So there's a 1 out of 36 chance, which is 0.028. So there's a 2.8% chance, not very likely, that you'll get 2 6s in a row. Okay. In this example, it says you have 5 blue pens and 3 black pens in your bag, And you reach in and you grab 2 pens, one right after the other. So you're not grabbing one, looking at it, and putting it back in the bag. You're grabbing 1, 2, 2 in a row. Find the probabilities. So what I want you to notice here is since we're grabbing both, one pen and then we're grabbing another one without returning the first pen to the bag, these are now dependent events. And you need to pay attention to that when you're doing your second probability. It's not that important in the first one, but the second one. All right? So what's the probability of getting a blue pen and then a black pen? All right? Well, the probability of getting a blue pen, well, there are 5 blue pens out of how many pens are in your bag? Well, there's 8 total because there's 5 blue and 3 black. And then, so we're going to multiply, and then what's the probability of getting a black pen? Well, how many black pens are in the bag? There are 3. And since this first part, we were asked about getting a blue first, we are assuming, again, that all 3 black pens were still in your bag for the second draw. So there are 3 black pens out of how many? Now realize it's not 8 anymore because the first pen you took out of the bag is still in your hand. So now there are only 7 pens left in the bag. Okay, now you don't subtract all 5 blue ones because you didn't take all 5 blue ones. You just took one, and we're assuming again that it is blue because that's the probability we're finding. But you did take 1 pen out of your bag before doing this draw, and so this total number of possible outcomes has changed now to 7. So 5 times 3 is 15, and 8 times 7 is 56, and 15 divided by 56 is 0.268. So there's about a 27% chance that you will grab a blue pen and then a black pen. Now the second part of this example says, what's the probability that I draw a blue pen and then I draw a blue pen again, another one? And again, this is still without putting the first one back in the bag. Well, the probability of getting a blue pen, again, there are 5 blue pens out of 8. All right? And then once that pen is in your hand, and again, we're assuming it's blue because that's what we're trying to find the probability of, how many blue pens would be left in your bag now? Well, there were 5 of them. We're going to assume we got this to find the probability of getting a blue here. So now there are only 4 blue pens left in your bag out of 7 pens that remain in your bag. 5 times 4 is 20. 8 times 7 is 56. 20 divided by 56 is 0.357. Okay. Notice it's about 35–36% likelihood, which is a higher percentage because going for blue and then blue again when there are more blue pens in your bag to begin with means that you're more likely to get blue and then blue.